Okay, this is a presentation over adaptive radiation. Adaptive radiation is when organisms diversify quickly into new forms to adapt to environmental changes. This is a form of speciation which can be both allopatric or sympatric, and it creates many new species over short amounts of time. My example was radiation of the anolis lizards in the Caribbean islands. They're an exceptional example which have been used many different times for a lot of different experiments. They're all found in the chain of Caribbean islands and were discovered by Ernest Williams in 1972, where he divided them into ecomorphs and was the first to ever do such a thing. There's two examples of different anolis lizards. Radiation of these lizards occurred over 40 million years. So far, 400 different species have been discovered, and more keep being discovered every single year. These lizards have adapted for reasons such as climate, landscape, resources, and competitions. In some ways, climate has affected their body temperatures, and landscape and resources have affected structural body composition. Some examples of the radiation include limb length, body size, and body temperature. They were adapted in an early burst, which is where radiation occurs at a very fast rate for an early time and begins to slow down. The presence of subdigital toe pads and gular throat fans are more specific examples of adaptive radiation. There's a picture of the subdigital toe pads, and there's a gular throat fan, which is used for mating. Like I said earlier, they are divided into ecomorphs. These include the crown giant, the grass bush, the trunk ground, trunk crown, and twig forms. All of them are classified by physical and structural characteristics, such as twig forms being very thin, very fast, and agile, and crown giants being very strong and able to climb trees and that kind of thing.